There's a problem in energy and momentum. We have mass m, which is attached to a spring with constant k, and it's oscillating from one side to another with an amplitude a1. At time t0, we drop another mass, and that mass is attached here with the first mass. And we do that when the spring is at the relaxed length, which we denote by x equals 0. Which means we know that at that point there is no potential energy, it's only kinetic energy. We want to find the new amplitude of these when we have these two objects together, A2. So after the collision, what would be the new amplitude? And what would be the period of motion? So we start with the energy before the collision. I denote this by 1. As I said, before the collision we had only that mass and the spring was relaxed. So the only energy in the system is the kinetic energy, which has to be equal to the spring energy when it's at point A1 here, right? Due to conservation of energy at that point, there would be no kinetic energy. So basically, energy is moving from potential to kinetic and so on. So kinetic here, only kinetic energy here, and only potential energy at that point, but they have to be equal. So the energy at the beginning at t equals 0 has to be half k a1 squared. This is at x equals 0. We also know that energy, so half k a1 squared, has to be equal to the kinetic energy of the system at that point. So if v1 is the velocity at time t equals 0, that would be the kinetic energy at x equals 0. And these two quantities have to be equal. So from here we conclude that we can find V1. V1 is square root of k over big M times A1. We need the velocities in order to move to, when we move to conservation of momentum, we're going to make use of that. Okay, so at the beginning, now we go to conservation of momentum. We had m times v1, and that has to be equal to, well, after the collision we have m plus m times v2. So v2 is m over m plus m times v1. Now I can go back to the energy of the system after the collision, so E2. And we know that it has to be half the total mass now, m plus m. This is exactly after the collision at that point, times v2 squared. That's v2 squared, we can substitute, so it's half m plus m. v2 squared is m squared m plus m squared times v1 squared. So we lose this and this. So finally we find that it's m over over m plus m times mv1 squared with the factor half here, which I want to put on the other side there. And this is exactly E1, right? So the E2 is m over m plus m times E1. Now, on the other hand, we know that E2 is also half Ka2 squared. This is the point where it reaches the maximum amplitude. There would be no, there would be only potential energy. So now this has to be equal to what we have there. So now we can write this has to be equal to m over m plus m times E1, and E1 is half K A1 squared. So it's half K A1 squared. Okay, we lose the half K here and the half K there, and we find that A2, which one, the amplitude that we wanted to find after the collision, the maximum position from the relaxed length, is square root of m over m plus m times A1. And the period is 2 pi square root. Now we have m plus m over k. All right, now let's ask another question. What happens if we drop that mass, not when the big mass at x equals 0, but when it already reached the A1 here? So it's found here now, at A1, and we drop, let's do it in blue, we drop the mass here. Now we're going to ask the same thing: what happens to the amplitude and to the period? Now notice that if we do it at this point, there is no kinetic energy at that point, right? It's only potential energy from the spring. If there is no kinetic energy, it means there is no velocity. So the momentum before collision and after collision has to be the same. So the energy, the mechanical energy would be unchanged. Let's put this down here. Let's call this B. So now we have E1 has to be equal to E2. Or E2 has to be equal to E1. And that is half K A1 squared. In other words, there is no change with the amplitude. And the period in this case would be the same as before. We have the two masses, divided by the period, the K. Okay.